And remember, in 5.1, we talked about the idea of a relation. And a relation is some rule that associates one set of information with another. Okay? So, first set of information could be all of your names in this class. Your second set of information, or the second set of information could be hair color. So then the rule would be you're associating each name of student in this class with a hair color. Okay? Obviously, all the names would be, well, most of the names would be different. I don't think we have any doubling up anymore of names, do we? No. So every name would be distinct, but not every hair color would be, would it? Okay? Because we would put them under sort of general categories. Okay. Some other terms about relations. Something called the domain. We're going to hear a lot of these two words this year and the next 2 years. Okay? The domain of a relation is, sorry. All the elements in the first set of information. And the range is all the elements in the second set of information. So if I go to that example that I just gave you about all of your names and then hair color, all the elements in the first set of info would be all your names listed. So that would be the domain of the relation. The range of the relation would be all the possible hair colors. And then we could decide on, say, black, brunette, redhead, brown, gray, who knows? Okay, some of you are a little stressed these days, so gray may be coming in, who knows? Okay. That's what hair color is for, right? Why are you looking at me that way? Why do you hurt me so? Why do you hurt me? You're just looking at me in a disappointing way. That hurts my feelings. Okay. A function is a type of relation. Where every domain element has exactly one range element. Now that's a bit of a mouthful. So what I often like to do is just sort of say it like this, and students often find it much easier to remember like this. Domain elements never repeat. So if we go back to that example that I gave you guys again, about all the different names, right? Okay. If you think about the relation, and the first set of information, the domain is all your names, do any names repeat? No. Therefore, the situation I'm giving to you, not only would we call it a relation, we'd call it a function. Okay? If Madeline McKay was in this class, is every name different? No, therefore it'd be not a function, because one of the domain elements repeats. Okay, and we'll do a few, you'll see when we do a couple more examples here. So let's look at this one. Pretty simple relation. Last 4 months of the year with the number of days in that month. Okay, and we're asked to write a set of ordered pairs. So what is the fourth last month in the year? September. How many days does September have? 30. That's one ordered pair. The next ordered pair would be the next month, the third last, with the number of days, 1. And then the second last month, November, with the number of days, 30. And then December, I think we can all agree, 31. And then we put the fancy braces. So this is a relation, because we're relating the last 4 months in the year to how many days are in those months. Is it also a function? Look at the domain elements. Do you see any that repeat? The domain elements are all the first sets, so it's the months. You see any months repeat? It is a function. No months repeats. But what if we reverse the relation? What if we said, okay, I want to write a relation very similar to this one, except this time I want to relate the number of days in a month to the last 4 months of the year. So I'm going to reverse all of these. So 30 days for September, 31 days for October, 30 days for November, and 31 days for December. The same sets of information, but the rule is reversed. Is this a function? No, because 30 repeats and so does 31. So not a function, because the domain elements, or domain values in this case, because they're numbers, at least one of them repeats. So we could say domain values 30 and 31 repeat. Okay. So we don't necessarily have to write this down because we're going to see it. But when we have a set of ordered pairs, if we're showing a relation as a set of ordered pairs, the first values or words, those will be the domain. The second values will be the range. Okay? If the relation is shown as a table, and let's say we have x and y, all these values would be the domain. It's the first column. The second column in a table would be the range. If we did an arrow diagram, the first oval, so I should have written that in red. Domain. But first of all the elements or values in there, or words, whatever, will be the domain. And this will be the range. We also give these domain and range different names. And you guys hopefully will have seen this in science. Oh, sorry. We're not going to do that yet. We're going to do an example first. Okay, so for each of these relations, A and B, you have to state three things: domain, range, whether it's a function or not. Just going to put capital D for domain, and we usually start with braces. So what are all the elements in the domain here? Right triangle. Cube triangle. Square. Rectangle. And regular X. Just put reg X. What are all the elements in the range? And you don't, if it repeats more than once, you only have to list it once. So what would those be? 1, 0, and 4. You don't need to go 4 twice because it's already there. You don't need to do 0 twice. Is it a function? Remember, don't look at the range, look at the domain. Do any of these repeat? No. It is a function. For the second one, we've got an arrow diagram. What's the domain? 149. What's the range? Yeah, just list those numbers in the second order. You got to be able to read an arrow diagram properly. Is it a function? Somebody said no? Who said no? Why? Exactly. 2 arrows coming out of the 1, which means the 1 repeats. 2 arrows coming out of the 4, which means also the 4 repeats. So, not a function. Because we've got at least one domain value repeating. Okay. Now I can go to this. Relations and functions. Remember we talked about the domain and range. Another word we can use for the domain, or another phrase, and like I said, you've probably heard these in science, the independent variable. And then for the range would be the dependent variable, because it depends on what the independent values are. Okay? So in this example, the independent variable is always the first column. So the independent variable is hours worked. And all the hours that are listed would be the domain. The dependent variable would would be the gross pay. Anybody know what gross means in this context? I think we all know what the other definition of gross means. I guess none of you, anybody have a job where you got a check? Yeah? Okay. Anybody else who's got a first check? Yeah. Do you remember what it said on it? Okay. Gross pay is what you receive before any deductions are taken off. Okay. Certain deductions could be, and you guys are going to see this, is you have to pay income tax on what you make. So that's a deduction. When you get a full-time job, you may have to pay for a medical plan. That's a deduction. You may have to pay or for a medical plan, and then maybe a vision plan as well, separately. That's a deduction. The government takes certain amounts away. It's called Canada Pension and unemployment insurance. Canada Pension means that you're contributing to a pension plan that you guys aren't going to see until you're like 60 to 65. And then in addition to the pension you get from whatever job you have, or if you saved up RSPs, never mind, that's a whole different discussion. The government of Canada will send you a check every month because you worked and you contributed to the Canada Pension Plan. The unemployment insurance means that you're contributing to a plan where if for some reason you're out of work for some reason, you can collect what's called unemployment insurance for a certain period of time, which means you'll get paid while you're trying to find another job. Okay. These are very simple explanations, but anyway, the gross pay is not really what you get in the end. The money that you get on your check, the one that you cash into the bank and you see, that's called net pay. That's your net. That's the actual money you get. And all of you, at one point or other, will complain about your gross pay versus your net pay in the future. See, you're already shaking your head. Okay. Another example. Here we have two sets of information, both values, numbers this time. First set is number of marbles, and second set is their weights or their masses. Hey, looking at this, is it a function? Yes, it is, because none of these repeat. So we can just simply say no domain values repeat. What's the independent variable? Number of marbles. So the ND bar is the number of marbles. What about the dependent? The mass. Okay. Domain and range, you're listing all the elements in each. In this case, they're all values. So what would the domain of this relation be? 1 through 6. And the range will be the 6 masses. 1.27, 2.54, 3.81, 5.08, 6.35, and 7.62. Okay. Close that off. I'm actually going to stop there because I'd like you to do some questions where you're listing the domain and range and determining if certain relations or functions or not before we start to get a little bit more math, which is what the rest of the lesson is about. We're going to talk about notation. Okay, but we'll talk about that tomorrow. So really, you can do all questions in exercise 5.2 right now, except 4 to 8. You won't be able to do numbers 4 to 8 yet. We'll cover those tomorrow. So basically for months, so tomorrow I will finish the rest of 5.2, and then for Tuesday, because it's a Monday schedule, you should have exercise 5.2 done.